Good morning, everyone. In this video, I will continue the discussion with steps for the class design. Okay, so we'll be discussing about organizing a class design. So, in terms of the organization of the class design, programs actually consist of discrete physical units. These things can be edited, compiled, imported, and otherwise manipulated. Okay, so these discrete physical units. If you know about languages like C and Fortran, okay, so these basic units are the source files. So you can basically edit those source files, you can compile them, of course you can import them, okay, and also like you can actually manipulate them and then like do all sorts of things with those files, okay, source files. So similarly, like if you look in terms of Java as well, okay, so you have the files, but the interesting thing is like Java and other languages, something like other, the package structure is actually explicit language construct. We have seen in the labs. So you define the package as well for the classes. Okay, that sort of language construct, okay, so can be maintained in the source code in terms of the files. Okay, this is what we have been seeing, okay, in the Java language. But this sort of just maintaining these sort of physical units also goes to this sort of language level, not just the files but also like even the class files. I mean like even these source files, like you actually maintain that. Okay, we can actually improve this sort of organization of class design with several steps, especially with these following steps. We can hide internal information from outside view, okay, and then like we can maintain coherence of its entities, okay, so they should be concrete, okay, so they were talking about one thing, okay, and then like we can fine tune definition of packages. So we'll be discussing all these three, okay, in the coming slides. First, let us look at information hiding. So in this one, like we basically are trying to see like carefully separating this sort of external specification from internal specification. Okay, the information hiding fundamentally deals with this one. There are several ways to hide this information. Okay, so the first one is like limit the scope of the class model traversals. Say for example, there is one method which actually could traverse several associations of the class model to actually locate and access an object. Say for example, this object 1 wants to access object 2, which is in a different class type, but then like it is actually using several associations. This one is going to class 1, class 2, class 3, class 4. Eventually that object is of class 4, so then that's how like it is actually accessing that. This is a very bad approach actually. Such unconstrained visibility is appropriate during the analysis. During the analysis it is okay, so we can actually check it. But then like these when we come to the design, like we have to clear this problem actually. Methods that know too much about the complete model, how we have actually designed, because like it has to basically traverse across all these associations, means this method has a lot of information about the complete model itself we have developed as of now. So that means like if you are making any changes in the model, this operation actually has to completely change. So this model itself is fragile, okay, so if there are any changes in the model, so this method is invalid, okay. So this is a problem with this one. So during design, like we should try to limit this sort of the scope of any particular method, so it cannot traverse so many associations, okay. An object should access only an object that is directly related, okay. Only if you have a direct association, it is better to use that particular object in the first object. Okay, this is one way of information hiding. So you are actually trying to see like the model is not directly incorporated uh, into the implementation of that particular object or that particular method. The another way of doing this one is like do not hide access to do not directly access foreign attributes. Say for example, like you have an association to another class, okay, class 1 is associated with class 2, okay, but don't directly access the attributes of class 2. Don't directly access the attributes of the associated class. Call an operation in this associated class, okay, to access those attributes. Okay, that is how we should be doing. So do not directly access the foreign attributes. Then we have to define interfaces at a high level of abstraction. Okay, so these are actually desirable to minimize these sort of class couplings. Okay, So class coupling actually deals with, say, for example, from with how many methods of class A, okay, are actually using the association to class 2. Okay, that actually shows like the strength of the coupling. Okay, it is better to minimize this sort of class couplings. One way to address this one is by raising the level of abstraction of interfaces. Okay, so basically like have more interfaces. Then the other approach is by hide external objects. Okay, so we can use these boundary objects to isolate the interior of a system from its external environment. So these boundary objects actually act as mediates, okay, that actually for this request and responses between inside and outside of the system. And these boundary objects actually take care of the transformations when requests are coming in and then like responses are going out. So these things are to be transformed the way like how the external system understands it, how the way like internal system actually deals with those calls. So these transformations also fall the responsibility of the boundary object. Another thing which we should consider is like we should avoid cascading method calls. Say for example, like you take a method, take its result, okay, use it in a different method, okay, take its result and use it in a different method. This way, like you will not be able to coordinate or like later be able to understand or manage these sort of cascading method calls. Okay, if it is actually required, okay, so use a single method, single operation to basically include both the things and then like have a single result coming out of that particular operation. Okay, so avoid cascading method calls. So these are different ways to basically hide the information. Then let us look at the second one, coherence of entities. Okay, an entity such as a class or an operation and a package is coherent if it is organized on a consistent plan and all its parts fit together towards a common goal. So it should have a common goal, and that's how like you are actually putting all things together. Okay. So in that sense, like an entity should have a single major theme. It should not be a collection of several unrelated parts. Okay. So to give an example, I mean like to discuss more in detail about this thing. Okay. A single method should not contain both the policy and also the implementation. Okay, this is at the method level or at the operation level. So policy primarily deals with, say for example, making, okay, of context dependent decisions. Okay, so these policy methods may contain IO statements. Okay, so you will be asking some information from the user. Okay, you will be having certain conditions. Okay, and you will be accessing certain data stores, etc. So these are the things like policy operations. Okay, and then like implementation is actually execution of a fully specified algorithm. Okay, so don't have both the policy and implementation into a single operation. So then it is not very coherent. Okay, in that sense. So let me give you an example so that you actually understand it better. Assume like if there is bank account, like you basically have to calculate the interest. Okay, when to calculate the interest is actually the policy. Say for example, between this month and this month, and then like say for example, if there is say for example for a certain period, okay, uh, say for example like the account don't have enough money which needs to be maintained, that for that period like you are not calculating the interest. So these are all the policies. Now this one as a separate operation and calculating the actual interest, make it as a, okay, make it as a separate operation with the pure implementation. Why you have to do this sort of separation? Okay, because in that case the separation actually increases the possibility of reuse. Okay, so policy methods are less likely to be reusable across different applications. They're very easy to write. You can basically rewrite them, okay, based on the need of a different application which you use. But then like whereas like these implementation operations, they are perfectly reusable. Okay, so that's about the coherence for these sort of operations. So they are taking care of one thing and one specific thing and then like in a proper way. Similarly classes, okay, also the same thing actually applies for classes as well. A class should not basically serve too many purposes at once. If it is too complicated, break it. Better break it either using generalization or like aggregation. Break it. If there are smaller pieces, then there is more likely to be reusable, okay, than very large complicated pieces. Okay, if they are complicated pieces, you are not reusing them. Okay, during the other video also, during the previous video also, we have actually discussed. Okay, so if it is dealing with a lot of operations, okay, and if you want to reuse into a different thing, then you will basically end up with implementation generalization, implementation inheritance. Okay, the way like we have discussed during the previous video, and we also discussed like it is better to use delegation in such cases. So basically, like a class should be taking care of only one purpose. If it is doing several things, better break it, okay, using generalization or aggregation. Now let's get to the third one. Okay, so the fine tuning of packages. During analysis, like we actually partition the class model into packages. Okay, this initial organization may not be suitable or optimal for the actual implementation. During the analysis, like we had these packages, but then like they may not be ideal for the implementation side. We should define packages so that their interfaces are minimal, okay, and well defined. How do you define an interface between two packages? Okay, so these things actually consist of the associations that related to classes in one package to classes in another package. Say for example, if there are two classes, these two classes are associated. If they are existing in two different packages, okay, then there is a serious interface between them, between these two packages. Similarly, like say for example, there is a class, there is an operation in this particular class in package A, for example, and this has to access the classes across a package boundaries. Then that means like again like you have very strong interfaces between these two packages. We already have seen about cascading. Okay, so operations, calling operations, and also like we have seen like operations traversing these multiple associations and then like going and using another object from a different package. These would be very bad way of structuring packages actually. So we can actually use the connectivity of the class model. So now you have more or less the class model until and unless like you are iterating and then like you are actually improving across the object oriented complete development. Okay, you went back to analysis and then like you came back to design, but more or less like now you have your complete class model at this stage. And this class model actually, we can see the connectivity in this class model, and we can form general guidelines for forming packages. So classes that are actually closely connected by association should be in the same package. Okay, unless there is a specific reason for that one. Package should also have very some theme. Okay, and they should have some functional cohesiveness. They should be together, and some unity of purpose. So you should put all the classes in a package based on some, okay, based on some theme like that one. Okay, of course, like if classes have associations, but then like they differ a lot in terms of theme, then you basically separate. That's how like you are having associations across packages. So I already talked about coupling actually, okay, earlier already in this video. But the number of different operations that actually traverse given association, if there is association between class A and class B, how many of these operations in class A are actually using that association? How many operations? How many operations? This is actually a good measure for coupling strength. Remember this one. It is like how many operations that are actually using the association, not how many times like you are using that association, not the frequency of traversal. Okay. If two classes are very strongly coupled, it is better to use them in a single package. Try to keep strong coupling within a single package. So that's about these three approaches. Okay. So with this one, like we are finishing chapter 15. Okay. So of object-oriented modeling and design. Okay, with UML, Michael Blaha and James Rumbach. So basically with this one, like we have finished the class design. Thank you very much for your attention.